Auzubillahiminash-shaytanir-rajeem. Bismillahir-rahmanir-rahim. Dear students, Assalamu alaikum. This second video lecture of week 14 for the course Numerical Analysis is the continuation of my previous first video lecture of this week 14. In the first video lecture, we have discussed numerical integrations and numerical integrations by trapezoidal rule. We have already discussed trapezoidal rule with some explanations, and now we are going to discuss again the trapezoidal rule with some examples. In the previous video lecture, we have discussed trapezoidal theory of trapezoidal rule, and now we are going to discuss this trapezoidal rule by some examples. Suppose you see over here we have a definite integral from 1 to 2 1 over x with respect to x. We are going to take the integration of the function 1 over x from 1 to 2. Integration from 1 to 2 of the function 1 over x with respect to x. So approximate this integral with n is equal to 5 using the trapezoidal rule. N is equal to 5 mean we will construct 5 trapezoid from the curve of this function. So first of all, find the value of the step size delta x, which is represented h. Delta x mean h is equal to b minus a divided by 2. So 2 minus 1 divided by 5. So the step size is 0.2. Now the trapezoidal rule area h divided by 2 into f of x naught plus f of xn. Actually the last value is 2 and the first value, the starting value of the integration is 1. So the first the value of the function at this first interval and the value of the function at this last interval naught will be the multiple of 2 and other values will be the multiple of 2, and you can easily construct the table putting 1 in the function. This is actually called f of x naught. You see over here in the formula, this is actually f of x naught, f of x1, f of x2. So first of all, find the value of f of x naught. F of x naught mean y naught, and if we consider this is x1, then the value will be called f of x1. So putting 1 into the function, you will obtain the value of the function at 1. Now putting 1.2, where comes 1.2? Where the 1.2 is calculated by this step size. Actually step size is 0.2. So 1 and adding the step size, so the next value of the x will be 1.2. Now putting the value 1.2 in the function, now the next value according to the step size will be 1.4, and similarly the next value according to the step size is 1.6, 1.8 and 2. So putting x is equal to 1 in the function, we obtain 1 over 1. Now putting x is equal to 1.2 in the function, we obtain 2 divided by 1.2. This 2 actually created in the trapezoidal rule formula. The function value at the first interval and the function value at the last interval will be not the multiple of 2 and other values will be the multiple of 2. So this is actually 1 over 1.2, 1 over 1.4, 1 over 1.6, 1 over 1.8 and 1 over 2 and 2 to cancel. So taking common 2 from the other values, and the first result and the last result will be free from the multiple of 2. So after calculations we obtain 0.69635. So dear students, I would like to tell you again the procedure. This is the first value of the interval and this is the last value of the interval. So put this 1 and this 2 in this given function, but this value and the last value will be not the multiple of 2. Now putting other values of x according to the step size. The first value is 1 and the other value is 1.2. The next value is 1.4, 1.6, 1.8 and the last value is 2. Now putting all these values according to the step size, actually there are 5 trapezoids, so b minus a divided by 5 according to this calculations, the step size is 0.2. Now h by 2, 0.2 divided by 2, and the first value in the function, second value according to step size is 1.2. According to step size, other value is 1.4, 1.6, 1.8, and the last value is 2. Now putting all these values in the given functions, and the last value of the function in the first value of the function in the last value of the function will be not the multiple of 2, and other values will be the multiple of 2. Now after calculations, we obtained the numerical area. The approximate area is 0.65 or 0.695635. So you can also calculate the integration by using the fundamental theorem of calculus. Integration of 1 over x is log x. Now putting the upper limit in the lower limit, log 2 minus log 1. Log 1 is 0, and the log 2 value is 0.693147. So there is some error, because you see over here, this is the exact result and this is the approximate result by using the trapezoidal rule. So the error, exact result minus approximate result, the error is minus 0.002488, and the absolute error will be plus 0.002488. Now another example, to use the trapezoidal rule to approximate the integration from 0 to pi of the function sine x with respect to x. Compare the results with the compare the approximate result with the exact result, and now calculate the approximate result for n is equal to 4 and for n is equal to 8. For n is equal to 4 mean we can construct 4 trapezium, 1, 2, 3 and 4. So the first value is 0, and now according to the step size, pi minus 0 divided by 4. So pi by 4 will be the step size. So the first value is 0 of x, and the second value of x is pi by 4. Other values pi by 2, 3 pi by 4 and pi. Now putting all these value of x in the given function, you will obtain the other values. So putting all these values in the given functions, you will obtain the results after putting the x values 0, pi by 4, pi by 2, 3 pi by 4 and pi. Pi is the last value of the x. So the first value, the first result, this is the x is equal to 0 and x is equal to pi. The other value is not the multiple of 2, and now the value of x is pi by 4, pi by 2 and 3 pi by 4. In these values will be the multiple of 2. So this is actually the step size h divided by 2. Since the step size h by pi minus 0 divided by 4 is pi by 4, and pi by 4 mean h divided by 2 mean pi by 8, 2 for the 8. Now after calculations we obtain pi by 8 into 0 plus under root 2 plus 2 plus under root 2 plus 0, and after simplifications we obtain pi into 1 plus under root 2 divided by 4, which is equal to 1.869. and now the exact result of the function, the exact integration of the sine is minus cos x, and now putting the limit, upper limit minus lower limit, we obtain 2. So this is the exact result. Now we can calculate the errors. Exact result minus approximate result, the errors is 0.104. Now putting n is equal to 8, the step size will be pi by 8. b minus a divided by 8, pi minus 0 divided by 8. So the step size is pi by 8. Now the first value of the limit is 0, so sine 0, and the last value is pi, so sine pi. These are not the multiple of 2, and other values will be the multiple of 2. But according to the step size, the first value is 0 of x, and the second value of x is pi by 8, and according to this step size, the third value is pi by 4. Other values is 3 pi by 8 and pi by 2, 5 pi by 2, 5 pi by 8, 3 pi by 4 and 7 pi by 8. How we can calculate all these value of the x? The starting value is 0. Now adding the step size, you will obtain the next value, pi by 8. Now again adding step size to this value, pi by 8 plus pi by 8, actually 2 pi by 8, 2 pi by 8 mean pi by 4. Now again adding pi by 8 to pi by 4, you will obtain this value, and now again pi by 8 you will obtain this value, and similarly adding the step size to the value, you will obtain the next coming value. And now after simplifications by using scientific calculator, you see over here pi by 16 into 2 sine 0 is 0, and now calculating all these values you will obtain 2 plus 2 under root 2 plus 4 sine pi by 8 plus 4 sine 3 pi by 8, and after simplifications we obtain 1.974. and since you see over here the exact integration of the sine x is minus cos x, and putting the limit, upper limit minus lower limit, we obtain 2. Now this is the exact result and this is the approximate result. Now the error is exact minus approximate result is 0.026. So dear student, you see over here the number of trapezium is 8 and the error is 0.026 between the approximate integrations and the exact integration result. And you see over here in the next slide, in the previous slide, here n is equal to 4 mean 4 trapezoids. The result is 1.896 and the error is 0.104. So one point should be noted: if we increase the number of trapezoids, you will get the most accurate results from the trapezoidal rule of the definite integrations. So why here error is less as compared to the previous calculations when n is equal to 4? Because n is equal to 4 mean 4 trapeziums and n is equal to 8 mean 8 trapeziums. So when we increase the number of trapeziums, we will get the most accurate results from the definite integrations. Now another example, to approximate this integration from 0 to 1 under root 1 minus x square with respect to x. So you see over here, this is the trapezoidal rule formula: h by 2 y1 plus yn. The first value of the function and the last value of the function will not multiple of 2, and other values will be the multiple of 2. So first of all, since using 5 intervals mean the number of n is equal to 5. So 1 minus 0, b minus a divided by n. 1 minus 0 divided by 5 mean 1 over 5. So the step size is 1 over 5. So the first value is 0. Now putting x is equal to 0 in the given function, you will obtain the value of the function is 1. Now 0.2, putting the value of x 0.2. 0.2 actually calculated by the step size formula. You see over here, this is step size. h is equal to b minus a divided by n. But we have the number of trapezium 5 intervals, 5. So b minus a mean b value is 1 and the a value is 0, so we obtain 1 over 5. So this is actually the step size. So 1 divided by 5 mean 0.2. So the step size value is 0.2. The step size value is 0.2. Now adding this 0.2 to the initial value, you will obtain the next value of x is 0.2. 0 plus 0.2, the next value is 0.2. So putting the value of x is 0.2, the function value is 0.9797. Now adding this step size to this 0.2, the next value of x is the 0.4. Putting x is equal to 0.4 in this given function, you will see the value of function is 0.9169. Now putting 0.6 in the given function, the value of the function is 0.8. Similarly, putting 0.8 in the given function, the value of function is 0.6. Now 0.8 plus step size, the next value is 1 and the function value is 0. So putting x is equal to 1, x is equal to 1 mean this is the last value. Now stop the calculations, stop the procedures, and these are all the values of the function. When you put the value of x is equal to 0, x is equal to 0.2, x is equal to 0.4, 0.6, 0.8 and 1. Now putting all these values in this formula, the first result and the last result of the function will be the multiple of 2. This is the first result of the function when we put x is equal to 0, and when we put x is equal to 1, this is the last result of the function. So these two values will be not the multiple of 2, and other values will be the multiple of 2. Adding other values and multiplied by 2, you see over here, this is the approximate integration result of the function 0.75924. Now we can calculate this definite integration by using the fundamental theorem of integrations. By using substitutions, you can calculate this definite integration. Suppose we put x is equal to sine theta, then dx by d theta is equal to cos theta. In now putting these substitutions, we obtain the integration 1/2 into 1 plus cos 2 theta into theta. Now calculating this integration and putting the limit, you will obtain the exact result 0.7853. And we can also calculate the area of this function. Actually this function represents this figure you see over here, and this is actually the one part of the circle. So the area here pi by 4, and pi by 4 means 0.7857. Suppose this is equal to y, then y is equal to under root 1 minus x square, and y square is equal to 1 minus x square, and now x square plus y square is equal to 1. This is actually represent the equation of circle through origin, and from 0 to 1 mean this is actually the part of the given equations. So pi by 4, now the area of this part is pi by 4, 0.7853. Now we can find the error by using the exact, subtracting the approximate result from the exact result. This is the exact result and this is the approximate result. 0.7853 minus 0.75923 is equal to 0.02606. Now another example, suppose we have a function y is equal to x square plus 2, and the domain value, the x value is from 0 to 4. So according to the intervals, copy the following table, mean complete this table and then complete the table, and then find the area by using the trapezoidal rule for the functions. So putting x is equal to 0, you will obtain this column. Putting x is equal to 1, we obtain the value of y. Putting x is equal to 2, we obtain the value of y. Putting x is equal to 3, we obtain the value of y, the value of function. Y mean function. So putting x is equal to 4. But dear student, you see over here, here the number of n is equal to 1. The step size is 1. H is equal to 1. 0, 1, 2, 3 up to this 4. So the step size is 1. Now b minus a divided by h means 0. b minus a divided by h. b minus a divided by n is equal to h. H is equal to b minus a divided by n. So since h is equal to 1, so 4 minus 0 divided by n is equal to 1, and now n is equal to 4. So there are 4 trapezoids, 1, 2, 3, 4. You see over here in this figure there are 4 trapeziums. So putting n is equal to 4, so b minus a divided by n, 4 minus 0 divided by 4, so the step size will be 1. Now complete this table, and now putting all these values in the given formula, you will obtain the approximate area for these functions. The value of x is 0, so the value of y is 1. Now putting x is equal to 1, the value of y is 2. Putting x is equal to 2, the value of y is 5. Putting x is equal to 3, the value of y is 10. Putting x is equal to 4, the value of y is 17. So 0 and 17 will be not the multiple of 2. So 0 plus 17 and 2 plus 0 plus 17 plus 2 and 2, this value plus this value and plus this value. H divided by 2, the area of these functions will be given by the formula h divided by 2. H here is 1, so 1 divided by 2 and 2, 0 plus 17 plus 2 into value of this plus 2 into value of this plus 2 into value of this. So this is the home task for you to calculate the area of approximate area of this function. Even we can easily calculate the exact value by taking the by taking the integration by using the fundamental theorem of calculus. So dear students, you see over here there are some examples for the discussions of trapezium for the trapezoidal rule. By trapezoidal rule, we can calculate the approximate value of the finite integration. For the trapezoidal rule, we need these two intervals 0 to 4, a to b. We need the value of a and the value of b, and we need the number of trapezoids. when the value of b and the value of a in the number of trapezoid is given, then we can find the step size. So you see over here in the formula there is a step size. So the step size formula is b minus a divided by n. B is the upper limit, a is the lower limit, and n is the number of trapeziums, the number of trapezoids. So first of all, find the value of h, and then calculate the other values of x intervals from 0 to 1, suppose. So the first value is 0. Now adding this step size, you will obtain the second value. Then again adding this step size, you will obtain the third value. So adding this step size to the previous value, you will get the next value, and we can calculate the table from 0 to 1. Now putting all the values of x in the given functions, you will obtain the value of the function, and in the formula, the first value of the function and the last value of the function will be not the multiple of 2. You can easily add these two values, the first value and the last value, and add the other values of the function, add the values of x, and then multiply it by 2. You can easily calculate the area of the function by using the trapezoid rule. And now this is the end of this segment. Thank you. Allah Hafiz.